Welcome to a lesson on determining the value of an annuity on the TI84 graphing calculator. The goals of the video are to define an annuity and then also to determine the value of annuity on the calculator. Now I do have another video that shows how to use the formula by hand to determine the value of an annuity, but this video will focus only on using the graphing calculator. An annuity is a sequence of equal payments made at equal time intervals. An example would be an IRA or individual retirement account, where, for example, you may make monthly deposits into an account in hopes of accumulating enough money to retire someday. The value of an annuity is the sum of all of the deposits with all the interest earned. This video will only address ordinary annuities when the payments are made at the end of each period. If the payments are made at the beginning of each period, it's called an annuity due. So in the previous video, we used this formula here to determine the value of annuity, and now we'll show how to do it quickly on the graphing calculator. Let's go ahead and take a look at our first example. Let's say at age 30 you deposit $150 at the end of each month into an IRA that pays 4% interest compounded monthly. At age 65, what will the value of the annuity be and how much interest would you have earned? So let's get our calculators out. We're going to press the Apps key, which is here. Then we're going to select the Finance menu, so we're going to press Enter. Then we're going to select the TMV solver, so we're going to press Enter again. Now there are a couple of ways to solve this on the calculator, but I like using the TMV solver. What we're going to do here is enter in all the values except for FV for future value. So N represents the total number of compounds over the 35 years. 35 years because we're starting at 30 and ending at age 65. So the number of compounds per year is 12 because it's compounded monthly. So N is going to be 12 times 35. I stands for the interest rate, which is 4%. Present value, when we start, would be 0 because there's no money in the account to begin with. The payment is the amount that we're going to pay each month, which will be $150, but since we're paying it, we're going to type in negative 150. We'll leave the future value alone for right now and scroll down to P/N, that stands for payments per year. Since it's monthly, that'll be 12. C/year stands for compounds per year. That'll be 12 as well. And as we mentioned before, we're going to make payments at the end of each month. Now let's go back up to FV for future value. With our cursor here, we're going to clear this value. We press alpha enter, it will solve for the future value given what we've entered. So the future value would be $137,059 and approximately 64 cents. Let's go ahead and write that down. Now let's talk about the second question that asks how much interest would you earn? Well, the interest earned would be equal to the account balance minus all of the deposits. So if we take the balance of the account and then we subtract all of our deposits, each deposit was $150, so times 12 would give us the amount of the yearly deposits, and then we make these deposits for 35 years, so times 35. So this account would have earned $74,059.64 over the 35 years. Now let's take a look at the second example where it's the same problem, but instead of starting at age 30, how would it affect the balance if you started at age 40? So if we go back to our calculator, you're going to press Apps, Enter, Enter, and now we're going to have to change the value of N because now we're only making deposits for 25 years, so N is going to be 12 times 25. Everything else should remain the same, 4% interest, a 0 present value, a payment of $150 per month, 12 payments per year, and 12 compounds per year. So let's go down to future value. We'll clear this and press alpha enter. And now the balance at age 65 would only be $77,119.43. And let's go ahead and figure out how much interest was earned in this situation. Go back to the home screen, second quit. So starting with the balance of the annuity at age 65, we'll subtract the total deposits into the account. So each deposit is $150 times 12 for each year, and then for 25 years, so times 25. This will give us the total amount of interest earned, which is $32,119.43. So maybe the outcome is a little bit surprising. If we start at age 40, the annuity will have a value of a little over $77,000, and we would have earned over $32,000 of interest. But if we start just 10 years earlier, the value would be much higher at $137,000, and we would have earned over $74,000 of interest, or more than twice the interest over the extra 10 years. I hope you found these examples helpful. Thank you for watching.